So when we are doing unit conversion, then it's just fun for children to have this sort of the unit poem, right? Millicentidecimeter, deca, hecto, kilometer. So if this is something they practice, you can start it with. It just be a fun activity where they also understand why when they go millicenti are related as a factor of 10, but like 10 millimeters make a centimeter, but 10 meters do not make a kilometer, because there's still a way to go, right? So from milli to kilometer you'll get from meter to kilometer you'll get from meter, deca, hecto, kilometer. So there are basically 3 zeros and not just a single zero, because for deca it was 10 meters to make a deca, and 10 deca, which is basically 10 times 10 meters, and 10 hecto, which is basically 10 times 10 deca times 10 meters. So the confusion of why is sometimes that you're using 10, sometimes using 100, sometimes you're using 1000, from, for example, going from centi to meter. That sort of clarifies if you play with the unit poem, which is millicenti, decimeter, deca, hecto, kilometer. And if you do it in the whole class and children are doing it, you can learn it very quickly, and it can be a nice sort of game that children play to say how fast can you say it, and how many will be there in between centi and a meter, right? So how much to get from centi to a meter, how much to get from meter to a kilometer. Even if you don't really care too much about the others and you want to concentrate just on these, no problem, you can concentrate on these. But you know how many are there in between. So milli to centi is a factor of 10. You need 10 millimeters to get a centimeter. But to centi to meter, centi, decimeter. So from centi to meter you need 100. And deca, hecto, kilometer. So for deca there is a factor of 10, hecto there is a factor of 10, kilo there is a factor of 10. So 1000 meters is what makes a kilometer. For all these unit conversions, it's very important that children are very comfortable with working with multiplication by 10 and division by 10. So obviously multiplication by 10 is the easier thing to start with, and I would start with a number. So let's say if I say okay, I'm going to multiply 24 times 10. Yeah. What does it mean? So you go back to 24 and you say okay, that's 20 and 4, right? And when I'm multiplying by 10, it means each of the ones I get, when I have 10 of these, 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 10 of these. So each of the ones becomes a 10. So I actually have 40. Right? And then each of the 10s becomes 100. So you can literally show it. You can say okay, when I multiply by 10, each of the ones grows up like to be a 10. So that's your 40. So these got multiplied by 10. And then each of the 10s grew up to become hundreds. So that's my 200. You need a different color to represent your hundreds. No problem. So use different colors for different digits. And then it will become obvious that the 24 is retained, but you are getting an extra 0. And all the numbers are getting shifted left. Once you've done it with whole numbers, then you can move on to decimals. And then you can say, okay, so now I have the same 24, but I also have 0.7. Now what is 0.7? It means one of these is cut into 7 pieces. So thin plates. So you have thin 7 of these really small plates. And when you multiply that by 10, right? When you multiply that by 10, then what happens is that these small plates become ones. So that becomes 7 ones. And then of course as before your ones becomes tens and your tens becomes hundreds. So again you will first focus on multiplication, and once the children are comfortable enough with regular multiplication, decimal multiplication, then you can move on to division with the tens.